Scientists have discovered thousands of new creatures living at the very bottom of the Mariana Trench. It's not the sheer number that's shocking, but how bizarre and unusual they are, defying the standard rules of science. It turns out, the most remote place on Earth isn't an empty, pitch-black abyss. It's a thriving, hidden ecosystem, which can change everything we know about deep-sea biology. In 2025, a groundbreaking discovery was made. A deep-sea expedition found the most extensive chemosynthesis-based ecosystem. It's not about isolated traces of life. Researchers documented thousands of new life forms, including approximately 7,500 microbial species. 90% out of it were completely unknown to science. Scientists confirmed that life down there isn't just surviving, more like thriving. They found highly active animal communities, operating at different crushing depths, discovered entirely new species, and even recorded the deepest fish ever observed. How is this even possible? At nearly 36,000 feet below the surface, it's treated pretty much as an alien world right here on Earth. The pressure down there can simply crush a nuclear submarine like an empty soda can, as it's over 1,000 times greater than its sea level. Up here on the surface, every living thing ultimately relies on the sun for survival. But down there in the Mariana Trench, sunlight simply doesn't exist. Instead of that, the newly discovered organisms are powered by the Earth itself. Feeding on toxic chemicals, heavy metals, and even raw geological gases leaking from the ocean floor is called chemosynthesis. We know what they're eating, but what about the enormous pressure? These extreme life forms have developed unique cellular structures acting like a fluid that prevents their bodies and the DNA inside them from collapsing under the immense weight of the ocean. Now, we need to shift our understanding of the Mariana Trench and begin to consider it as an active, living laboratory operating in the dark. Finding an entire ecosystem down there proves one terrifying thing. We actually have no real clue how our own planet works.
There is a place deep in the ocean where pressure is 1,000 times stronger than that we're used to at the surface. This force is enough to turn an unprotected human into dust instantly. Well, maybe more like mud. Anyway, that's why explorers need some serious preparation and equipment to survive in such extreme conditions down in the Mariana Trench. It is as wide as 20 national malls in Washington, D.C., and about 1/5 as long as the diameter of Earth. People who went all the way down describe it as a chilly, quiet, and very peaceful place. They saw a bright blanket of red and yellow rocky outcrops, and there was a whole variety of unique, small, translucent animals. The popular myth is that more people have gone to the moon than to this deepest place on Earth is not true, though. In total, 24 humans flew to the moon, and at least 27 brave souls dove down to the Mariana Trench. Most of them were explorers and not proper scientists. They just go there for the thrills and also to collect video evidence of different wildlife, geological formations, and human-made objects. Humans started traveling around space and into the ocean depths at around the same time. The first moon landing was in 1969. And the first person to go down the Challenger Deep, the deepest part of the Mariana Trench, did so in 1960. This unusual location got its name after the British ship HMS Challenger, which first located this massive drop in the ocean floor at the end of the 19th century. It would take 8 more decades before the first human went down to it. Explorers didn't manage to do it in a conventional submarine. They used a type of submersible called a bathyscaphe. The Swiss oceanographer Auguste Piccard designed his own in 1953. 7 years later, the submersible managed to do the impossible. It had reached a depth of nearly 36,000 feet. But what explorers saw was merely a fraction of the trench's full size. The fact that it is so huge of the Mariana Trench is just one of the reasons why it's mostly unexplored today. The absence of light is another major issue. Sunlight is incapable of reaching such profound depths, so the entire trench, from top to bottom, lies in absolute darkness. Because of such conditions, the ecosystem is a lot different than the shallower regions of the Pacific. This puts immense pressure on marine wildlife. Yeah, the pun is intended. Another reason why it's so challenging to survive there is the temperature. Water freezes at 32 degrees Fahrenheit. At the bottom of the Mariana Trench, the ocean is just a couple of degrees above freezing. One of the factors that hasn't let this area turn into a giant icicle is the fact that salt water has a slightly lower freezing point. The other reason is geothermal energy that warms the ground at the bottom of these just enough for it not to freeze. That's why submersibles need to have proper insulation to navigate these icy conditions. When they reach the bottom, researchers find out that this desolate and harsh climate is home to several animal species. They encountered arrow-toothed eels, snailfish, and spoonworms at various depths. There were even strange-looking translucent sea cucumbers and shrimp-like amphipods. The biggest surprise was microbial mats thriving on methane and hydrogen from the mud. Among the species, the Mariana snailfish looks like a master of the environment that can go farther and deeper into the trench to feed on prey than its competitors. Despite its seemingly fragile appearance, the snailfish has adapted to withstand extreme pressures, a superpower it wouldn't be able to survive without. The exotic life forms that live deep down aren't normal-sized, since deep-sea gigantism makes them grow significantly larger than their counterparts in other ecosystems. One example is the giant tube worm, which can be 6 feet long. Science has a hard time explaining the exact cause of this form of gigantism. Thermal vents are just one of the possible explanations. All of these factors might help explain the huge time gap in researching the Mariana Trench. The first successful dive after the 1960 expedition came only in 2012. That's when the famous Canadian film director James Cameron went down in the Deep-Sea Challenger. Because few scientists have gone that deep before or after Cameron, there is no map of the deepest point on our planet. We know very little about the oceans that cover 2/3 of the Earth's surface. Researchers have mapped out only 5% of them so far. Science still has a lot to discover in the Mariana Trench and other unexplored places on our planet. The Amazon rainforest stands as the best example of the world's most unexplored regions. The list of reasons why this part of South America is unknown starts with its wildlife. Jaguars, anacondas, piranhas, black caimans, and Brazilian wandering spiders are just some of the creatures that pose a risk for researchers. Relentless year-round rainfall induces heavy flooding. Add to all this some treacherous river currents, and you can see why scientists have mapped such a small percentage of the Amazon to date. In just one region of Brazil, near Peru, there are at least 14 tribes that have never had contact with the outside world. The national authorities intend to keep it that way. Isolation of these indigenous people is the best way to protect their future. The same goes for a remote island in the Indian Ocean. After the tragic tsunami of 2004, helicopters flew over North Sentinel Island to make sure its inhabitants were alive and well. Meanwhile, the Sentinelese weren't thrilled. They took up bows and arrows to drive away the unwanted visitors. This tribe is one of the last uncontacted tribes on Earth. Although anthropologists and filmmakers visited the island in the late 1960s, we still don't know much about its indigenous population. It sits a long way off any shipping lanes in the Bay of Bengal. North Sentinel has no natural harbor, and it's surrounded by a shallow reef. This makes access to the island possible only by boat. The Indian officials who lay claim to the island have prohibited outsiders from visiting the island for safety reasons. The estimates on how many people inhabit the island vary significantly, from as few as 15 to as many as 500. The island is not tiny. It's about 5 times as big as London's Heathrow Airport. Apart from occasional contact during the past 2 centuries, the Sentinelese must have been isolated for a long time. They are related to other indigenous groups in the Andaman Islands, but their neighbors cannot understand a word of their language. The continent of Antarctica has no permanent human settlements at all. The only people who periodically live there are international scientists. This vast expanse of ice and snow, roughly the size of the United States and Mexico combined, still has many regions where humans haven't set foot. Satellite imagery and photos that NASA's aircraft made from the air have mapped out the entire continent, so we know where to go, but it's not that easy. The reason for this are all the adjectives that go with Antarctica. It is the coldest, windiest, driest, and brightest of the 7 continents. This makes it virtually unlivable. More than 99% of its surface is covered with a permanent sheet of ice. Its thickness ranges from 1 mile to as many as 3 miles in some places. That's half the height of Mount Everest. Now, the Himalayan range contains the world's tallest unclimbed mountain. It is also the tallest mountain in Bhutan. In the local language, the mountain's name translates as White Peak of the 3 spiritual brothers. Out of respect for the spiritual beliefs of the local population, national authorities restricted and then completely banned mountaineering at the beginning of the 21st century. To this day, there is no evidence that any climber has ever managed to successfully reach the summit of this mysterious mountain.
An eerie, otherworldly sound is coming from the deepest and one of the scariest places on Earth, the Mariana Trench. First recorded in 2014, these sounds are so strange that they defied explanation for years. Dubbed Biotwang, these noises lasted only between 2 and 3.5 seconds. Yet in that brief time, they managed to send chills down the spines of anyone who heard them. The weirdest theories popped up to explain them. Some said it could be the cry of a deep-sea monster, a signal from extraterrestrial life, or something even more unsettling. But scientists think they have finally figured out the truth, and it has to do with wild sea creatures. At almost 7 miles deep, the Mariana Trench is the darkest, most remote part of the Pacific Ocean. Only a handful of people have dared to venture down into its crushing depths, and it remains one of the most mysterious places on the planet. In 2014, when underwater gliders patrolling the trench for acoustic surveys picked up these strange noises, scientists knew they were onto something big. But they had no idea what. The noise can be divided into 2 distinct parts. It starts with a deep, rumbling sound that echoes through the depths. And then, a bizarre series of sharp, metallic clicks. That some have compared to the noises made by spaceships in Star Trek. 2 years after the sound was first recorded, some scientists proposed the first real theory about it, saying that it was most likely a call from large baleen whales. But the sounds were just too strange, too different, and didn't match any known whale calls. Still, it was only a hypothesis, and without visual confirmation, it remained just that, a guess. Fast forward 10 years to 2024, and researchers at the National Oceanic and Atmospheric Administration believe they've finally cracked the case. To get some initial answers, they knew they had to analyze their database, which had over 200,000 hours of ocean sound records. It's no easy task, though. With all the noise coming from boats, plants, marine animals, and the ocean's movement itself, figuring out underwater sounds can be pretty tricky. And we can say it is simply impossible to analyze it all manually. The solution was to create an artificial intelligence tool to investigate these recordings. This technique could help solve the mystery in a matter of months instead of years. Thankfully, this technology has succeeded and has been able to confirm that the culprit behind the deep, metallic sounds is indeed whales. But actually, a different species. The culprits are bride's whales. Bride's whales are truly oceanic giants, weighing over 40 tons. They have long, slender, blue-gray bodies gliding through the water with stunning grace. These beauties can be found across the Atlantic, Indian, and Pacific Oceans. One thing we know is that Bride's whales love warm waters. But hold on, something doesn't quite add up. We can't really call the water in the Mariana Trench warm, since the temperature at the bottom only goes up to 39 degrees Fahrenheit. So, what were these whales doing there? It seems that scientists have an answer to that. The data also showed a spike in biotwang noises during 2016, when a rise in ocean temperatures caused by an El Niño event led to an increase in the number of Bride's whales visiting the area. In 2021, on the contrary, there were almost no biotwang records at all. And that makes sense, because it was a La Niña year when the waters were cooler than usual. So yep, it makes sense that Bride's whales were present in the Mariana Trench in the past, and more importantly, they were the ones making the biotwang noises. The research spotted 10 of these whales near the Mariana Islands, and 9 of them were producing these strange sounds. It was not all a huge coincidence. These massive creatures were, in fact, behind the biotwang. But even with this discovery, more questions remain. Why are these whales making such odd noises in the first place? Specialists believe that it could be a form of communication, like a deep-sea version of the game Marco Polo. However, they still don't have enough information to say for sure. For now, the mystery behind the purpose of the biotwang lives on. On the bright side, the new tech they developed can now be used in tons of other studies. It's a game changer for figuring out whale and other sea creature populations, and how they live and move around in Earth's mysterious oceans. And that can help us better protect these species. This isn't the first time strange sounds from the deep ocean and other remote places on Earth have left scientists scratching their heads. And unlike the noise from the Mariana Trench, we still haven't figured out all the answers to some of them. Take the Julia sound, for example. Which was recorded in the equatorial Pacific Ocean back in 1999. It lasted for about 2 minutes and sounded like a long, low growl. For years, people went wild with theories to explain it, wondering if it might be some kind of sea creature we hadn't discovered yet. Turns out, it was probably a giant iceberg that ran aground near Antarctica. But no one's confirmed this theory with 100% certainty. And then there's the famous Siberian sounds. In the 1980s, a group of scientists drilling in Siberia supposedly recorded what they thought were screams and groans coming from deep inside the Earth. Sounds crazy, right? According to legend, the noises were so freaky that rumors started flying about someone drilling a portal to the underworld. Whether it's true or not, the idea of accidentally disturbing something ancient and creepy deep underground is still a spooky story that gives people chills today. Now, one of the most famous deep-sea mysteries is the bloop. This noise was first recorded in 1997, and it got a lot of attention. It was so loud that it became one of the most powerful underwater sounds ever recorded. Since no known animal is capable of making a sound like that, some folks even speculated that it could be a massive sea monster, maybe even a giant squid. The bloop was picked up by a network of underwater microphones placed in the Pacific Ocean, and scientists now think it probably came from ice quakes. Events that happen when large icebergs crack and break apart. Even though that explanation makes the most sense from the scientific point of view, the legend of the bloop being linked to some enormous and unknown sea creature still sticks with people. Another sound that's been confusing scientists for years is
the upsweep. This weird sound has been echoing through the Pacific Ocean since 1991. It's made up of these long, sweeping whoops that go from low to high frequency over and over again. Some people say it sounds like a creepy ambulance siren, or maybe even a howl from some unknown creature. The crazy thing is that no one has been able to figure out exactly what causes it. And for some reason, it changes with the seasons, getting louder in the spring and fall. What is really strange about the upsweep phenomenon is that it doesn't have the usual tone variations you'd expect from something alive, like whales or other sea creatures. That's why some scientists think it might be tied to undersea volcanic activity. They're guessing the upsweep could be the sound of hot lava pouring into cold water. But even that hasn't been confirmed, so the mystery of the upsweep is still wide open, more than 30 years after it was first recorded. Next time you hear about eerie noises coming from the depths of the ocean, remember, it might not be extraterrestrial signals, but the truth could be even more fascinating. As technology gets better, so does our ability to record and analyze these deep-sea sounds, slowly unraveling the mysteries hidden beneath the waves. But for every mystery we solve, it seems like new ones pop up.
Can you swim? Good. Because you're going on a journey to the deepest point of the Pacific Ocean. Now put on your flippers. The very bottom of the Mariana Trench is awaiting. Now get in the water. Really, come on. All right. 1 foot underwater. That's the depth you can swim with no special gear like a mask. Hey look, must be some tourists. Or whales. 10 feet underwater. That's a little deeper than the public pools and beaches around the United States. You can see colorful fish and even phytoplankton that feed on the sun's rays. 26 feet down. This is the depth at which the foundations of the floating city of Venice in Italy stand. Builders laid columns at that depth on which they later built houses and streets. 30 feet underwater. You start to feel a lot of pressure. When you're on the surface, you're under atmospheric pressure, 15 pounds per square inch. But here, at 30 feet, that pressure is doubled. All the air pockets in your body, like your lungs or ears, begin to compress from this pressure, giving you discomfort. But no worries, your organs are soft and elastic, so you can keep diving. 40 feet underwater. Oops, you're running out of air. An average person can hold their breath for 30 to 90 seconds. The current record is an incredible 24 minutes and 37 seconds. Gasp. Okay, you'll need some diving equipment to continue your descent. There you go. Thank you very much. Tourists dive to this depth to look at reefs and corals. You don't need special skills for that, but you can't dive any deeper without training or a license. 45 feet down. Be careful. There's sharks swimming here looking for food, like you. Sometimes tourists descend to this depth in a safe cage to see the sharks up close. You're better off staying away from these predators and not attracting their attention. So make sure you're not wearing any bright and shiny jewelry. Sharks love that kind of thing. 62 feet underwater. You could see the Aquarius Reef Base Lab in Florida at this depth, if you were in Florida. It's really an entire building with rooms for exploring the seafloor, accessible through a hatch. 105 feet down. You see a strange bell hanging from a chain. People used to use these things for deep diving about 400 years ago. They'd lower a bell on chains with divers inside from a ship. There was enough air inside the bell for them to breathe. That way, they could explore sunken ships with treasures. 140 feet. At this depth, you could find an entire sunken city in Qiandao Lake, China. You can still see streets, houses, and temples there. 330 feet. Whoa! You almost hit a huge blue whale. How could you miss it? These guys, the size of 2 train cars, usually dive to that depth. Shh! Let's listen to them sing for a while. It's beautiful. Now, let's keep going. 660 feet. This is where most of the ocean life ends. Sun rays hardly penetrate any deeper into the water. Everything below are unusual fish like this angler. They have such an unusual appearance because they have to adapt to the high pressure here. 702 feet underwater. This is the last mark where you'd see a human without diving equipment. This man holds the title of the deepest man on Earth, and he's the only one who has managed to get to this depth. The water pressure on his body here was 20 times greater than that on the surface. 985 feet. Ooh, what was that sound? Whoa, that's a submarine. That's the maximum depth they can dive to. Some of them can reach speeds of 26 miles per hour. Fun fact, an ostrich can run twice as fast, but she can't swim. 1,090 feet. Say bye to this scuba diver. You won't see them any deeper than this. The world record was set in the Red Sea. It only took the diver 12 minutes to reach this depth, but it took him a whole 15 hours to return to the surface to avoid decompression sickness. So now you get an atmospheric deep diving suit. It's completely sealed, and you won't feel the insane water pressure on your body in it. 1,454 feet. If you stuck the Empire State Building in the water, its tip would be here, and all the carpet inside of it would be wet. 2,300 feet down. The water pressure here is 70 times greater than on the surface. The flexible plastic parts of your suit can't withstand that kind of pressure. So here's some urgent delivery. It's an ultra-deep submersible. Now you can continue your dive all the way down. 2,717 feet. Here you'd see the tip of the tallest building on Earth, the Burj Khalifa. Alright, who's sinking all the tall buildings around here? 5,387 feet. This is the depth of one of the oldest and deepest lakes in the world, Lake Baikal. Its area is slightly larger than the entire country of Belgium. 8,040 feet. That's the record depth the Perdido oil platform reaches in the Gulf of Mexico, and its above-water part with 3 decks is almost as high as the Eiffel Tower. 11,962 feet. This is the average depth of the Atlantic Ocean. You can see a huge tube as wide as a giraffe's neck, and it just seems to be endless. True, this cable connected Europe and North America and used to serve for telegraph communications. 12,303 feet underwater. Suddenly, in the darkness, you see the outline of a ship. No way! That's the Titanic itself. The intense water pressure would crush a person at this depth, so you can only dive down to the Titanic in a submarine. 13,123 feet. Whoa! Here would be the end of the deepest mine in the world, Imponen Gold Mine in Africa. But you still have deeper places to go. Let's speed up. 20,000 feet. Here you can see the deepest debris of an old ship. The USS Johnson sank more than 70 years ago. You can still clearly see the number 557 on its bow. 26,200 feet. Here, in this total darkness, you'll find the deepest fish in the world, the Mariana snailfish. They're as long as a domestic kitten and have almost transparent skin. Their eyes are poorly developed for vision because the sunlight never reaches this deep. 29,030 feet. If you take Mount Everest, flip it over, and stick it into the Marianas Trench, this is exactly where you'd see its tip. Even though this is the highest point on our planet, you'd still have a lot deeper to go. 35,755 feet down. Here, in the Challenger Deep, you'd still see life. You'd need a microscope for that, though. Bacteria living here feed on organic molecules, similar to oil. A little deeper? Congrats! You've touched the bottom. It's 36,070 feet deep. The pressure here is 1,071 times higher than on the surface. But you're not the first person to have been here. One of the last expeditions to the bottom of the Mariana Trench was in 2012. An American filmmaker descended here in a submarine he designed himself. But the pressure broke some of the engines, so it was hard for him to maneuver here. The sonar was also damaged, and some of the batteries drained. He was in the Challenger Deep for about 3 hours and took many pictures and videos. If you look closely at the bottom itself, you can see bubbles. It's carbon dioxide and liquid sulfur. It's freezing here because of the extreme pressure and temperature close to freezing. But there's still life here in these harsh conditions. The 3 microorganisms are most common here: xenophyophores, amphipods, and small sea cucumbers. There's so few of them because they don't have enough food down here. Usually, there's a lot of palm leaves on the ocean floor, which get there from the land. But the Mariana Trench is 124 miles from the nearest islands. So the only food here is old plankton and fish scales from the ocean's upper layers. But it needs to travel tens of thousands of feet to become food for the bottom dwellers. But can you go even lower into the crust of the Earth? Well then, you'll need to unleash your giant drill and fire up the jet engines. You're pushing another 36 miles through the Earth's crust, and here is its edge. You've entered the upper mantle. It's an ocean of hot lava, 1,800 miles deep. You have to literally swim through this, reaching the outer core, another 1,400 miles deep. Then you reach the inner core, another 755 miles, and congrats! You're at the very center of the Earth. I hate to ask, but how do we get out of here?
It's one of the most intriguing locations in the world. Covered in darkness and miles underwater, this extreme environment is home to some unusual creatures and phenomena. It's called the Mariana Trench, and it's the deepest oceanic trench on Earth. No wonder it's been so difficult to explore. Because of the risky conditions, people aren't able to explore this location without proper equipment. But what would happen if we threw a steel ball down there? Let's start with some basics. How did they first discover this enormously deep hole in the ocean? HMS Challenger identified it back in 1875. The ship had some pretty fancy sounding equipment for its time, but it wasn't nearly good enough to be able to fully explore the trench. Some decades later, in 1951, another ship, the HMS Challenger II, came back to the location better equipped. The vessel featured an echo sounder and was able to take accurate measurements of what seemed to be the deepest point on the surface of our planet. If you were to look at it in 2D, you'd see the trench measures 1,500 miles in length and 43 miles in width on average. It also looks sort of like a crescent-shaped scar when you observe it from above. Nothing out of the ordinary so far, right? Well, if you were to stretch a wire from the surface of the ocean to the trench's deepest point, it would measure a staggering 7 miles. If we were able to physically move Mount Everest, which is the Earth's tallest mountain, to cover the Mariana Trench, it still wouldn't be enough, falling short by about a mile. Because the Mariana Trench is so deep, it's almost completely covered in darkness, as light can barely get through to such extreme distances underwater. The temperature isn't any friendlier either, just a few degrees above freezing. But the most dangerous feature of them all is the water pressure. Right at the deepest point of the trench, the amount of pressure is about 1,000 times higher than the standard atmospheric pressure. Not a lot of people ever attempted to descend into the Mariana Trench. In fact, the first organized attempt took place more than 60 years ago. It was done by Jacques Piccard and Don Walsh in a submersible. They only spent about 5 hours on their descent and a mere 20 minutes at the bottom. Alas, they weren't able to take any pictures. Until these two scientists were able to descend, specialists believed there was little to no chance that life could exist down there, given the conditions, most notably the extreme pressure. But while at the bottom, the submersible's floodlight caught sight of a creature. It was a very flat one indeed. As you can imagine, resources here are very scarce. What kind of creatures live down here? And how do they survive, given the harsh environment? Surprisingly, there is quite an abundance of wildlife living in the Mariana Trench. Some of these creatures fall back on chemicals to survive, like methane or sulfur, while other kinds of fish nibble at the marine life that's, well, weaker than them on the food chain. The most common creatures found here are xenophyophores, amphipods, and small sea cucumbers. Some of them adapted by hardening up their shell using aluminum harnessed from the seawater. Smaller creatures, like microbes, adapted by feeding on the chemicals emitted when the seawater hits the underwater rocks. They consider the Mariana snailfish the rock star of the area in terms of wildlife. They're small, ranging from 3 to 9 inches, translucent, and lacking any scales. But they're the top beast of prey in the area. It's no wonder some people started to believe that the ancient megalodon might still be living here. What was a megalodon, you might be wondering? It was the largest predator ever known in our planet's history. Basically, the biggest and nastiest shark ever to have lived. Scientists believe it's been extinct for quite some time, and the idea that it might still be hiding in the Mariana Trench doesn't have a lot of supporting information. The megalodon would have needed to learn to navigate in complete darkness. It would either have to be bioluminescent or evolve to have massive eyes. More so, because of its school bus-like size, the megalodon would have needed a lot to eat. Microbes and small snailfish just wouldn't have done the trick. If a steel ball were to be dropped in the trench, what would be its effect on it? Would the ball be strong enough to sustain such pressure? Let's look at the science here. If we assume it's a solid steel ball, the pressure found at the bottom of the trench wouldn't be enough to really affect it and cause permanent damage. It would take it a solid 12 minutes to reach the bottom of the ocean, though. What about the temperature? Well, it turns out that the difference in temperature on the surface and at the bottom of the trench is quite impressive, a difference of about 86 degrees Fahrenheit. So, it would cause the ball to shrink a bit, but yet again, once the ball returns to the surface, it would simply come back to normal. Should the ball get stuck there, there's another interesting question to answer. Would corrosion affect it? Corrosion of steel is highly dependent on the amount of oxygen in the water. The amount of oxygen dissolved in water remains constant at depths greater than 3 miles. I'll spare you the math, but it would take more than 10,000 years for the steel ball to completely rust under the sea. I can't help but wonder, though, what would it take us humans to be able to survive at such extreme depths? Let's look at what was used in the past to explore this mysterious location. A little thing called syntactic foam. Why? Because it's the only material that can both float and resist the amount of pressure found here. Without this sort of protection, our lungs would rapidly collapse here. More so, the pressure from the water would push liquid into our mouths, replacing the much-needed oxygen with water. Then, there would be the much-needed ability to be able to come back to the surface should anything not go as planned. One of the vessels that went for a deep dive here had 1,000-pound steel weights attached to it, so it would ensure its sinkage. These weights were connected to the ship by a special type of wire that had an increased corroding time of 11 to 13 hours in seawater, just in case something went wrong down there, and they'd have to bounce back faster. Given the harsh conditions here, the problem of oxygen supply is really important too. Any vessel looking to descend into the Mariana Trench again would need to consider some sort of device that can recycle the air in order to reduce the amount of oxygen that needs to be transported down there. And the last, but definitely not the least of all problems, would be electricity. There surely isn't a power socket down there for you to charge your phone. So, there needs to be enough battery life to support all the necessary equipment, communication, oxygen supply, lighting devices, and so on. None of these problems seem to be quite the challenge anymore, since, as of recently, you can buy a tour of the Mariana Trench. 3 lucky individuals were part of such a project back in 2020. They were submerged in a 3.5-inch thick titanium sphere. This ensured that they didn't feel any pressure changes and physiological stresses whatsoever. Each of the guests took part in an individual trip that had an estimated length of about 14 hours. The descent itself took over 4 hours. Once they reached the bottom, they got the chance to witness some of the most extraordinary creatures on the planet. Then it was time to start the 4-hour ascent back to the surface. The Mariana Trench in the western Pacific Ocean is the deepest place on our planet. If you throw a rock into the water, it'll travel 36,000 feet before touching the bottom. But unlike your body, the rock won't experience any unpleasant consequences. After all, it doesn't get affected by all that immense pressure that builds up the deeper you go. But then, what would happen to your body at the very bottom of the Mariana Trench? Put on your flippers. It's time to dive. Hold your breath. You're 5 feet below the surface, and it's still pretty comfortable down there. You're used to this depth. You go that deep when diving in the pool, or maybe at the beach when watching exotic fish swimming near the bottom. But you're serious about reaching the deepest point of the Mariana Trench, the Challenger Deep. So you keep going. 32 feet. That's where you start to feel some discomfort. Here, the pressure pushing down on your body has doubled. Your ears and lungs feel a little sore. This is because people have many air pockets in their bodies. And under pressure, these pockets shrink in volume, and you can feel it. But don't worry, your organs aren't made of metal. They're flexible enough to withstand even more pressure than that. What you should worry about at this depth is the white shark. If it wants you for dinner, you're in worse trouble than high pressure. That's why you'd better keep diving. Around 65 feet underwater. That's where you'll need a flashlight and air tanks as you're running out of breath. The sun's rays barely reach here, and it's pretty dark. For the same reason, you're getting cold. How about putting on a thermal suit, which is what divers usually wear? Ah, it's better now. But even though you feel warmer, your ears are starting to hurt a lot. And your lungs have shrunk almost 3 times their normal size. This can be risky for an untrained diver. But you're brave enough, and now you're already at a depth of 100 feet. Only professional divers go that deep without special equipment. The pressure here is 3 times higher than what you experience on the surface. Something weird starts happening to your body. It's not like anything you've ever felt before. And the reason is your air tank. The compressed air inside is mostly nitrogen, 78%, and oxygen, around 21%. But that deep down, nitrogen becomes kinda toxic. It can make you do strange things, like you may forget you're underwater and pull off your oxygen mask. But if you take tanks with more oxygen in them, the dizziness and other strange sensations will pass. 200 feet below the surface. The pressure here is 7 times higher than on dry land. Now, even the oxygen becomes unsafe to you. You have to breathe some gas with helium in it. A sharp drop to a depth of 700 feet. This mark is the world record in free diving. Herbert Nitsch once managed to reach that deep without any special equipment or air tanks. After that, he received the title of the deepest man on Earth. In 2012, he tried to break his own record and plunged to a depth of 830 feet. But it didn't end well for his health. Anyway, if you trained to hold your breath for that long, you would probably have very few problems now. That deep down, you need to start looking around again because there can be heavy traffic. Submarines travel at this depth, and you sure don't want to collide with one of them. A few more feet deeper, and you've reached the limits of the average human's body. At the same time, laboratory experiments have proven that people can withstand even higher pressure. It went like this. A diver entered a special chamber the size of a room. Scientists simulated high pressure, comparable to a deep dive, inside this chamber. This way, the researchers discovered that a trained person can withstand the pressure similar to that at a depth of 1,600 feet. But the diver couldn't just walk out of the chamber after the experiment was over. At high pressure, nitrogen, helium, and other gases build up in the body. And if you normalize the pressure at once, those gases form into bubbles. The consequences are extremely unpleasant, to say the least. So, you have to do a gradual ascent from this depth. This way, the gases can leave your body in a natural way. Sometimes a dive takes a few minutes, but coming to the surface stretches for many hours. It's all about safety. Okay, now you have to put on a special suit. Otherwise, you won't be able to dive any deeper. It can protect you at a depth of up to 2,300 feet. The suit's sealed, and the pressure inside is exactly the same as on the surface. But all too soon, the suit's protection isn't enough anymore. You need a new means to continue your descent. And that's the Triton 6600 submarine. Now that you're sitting inside a large iron machine, you feel as if you're driving a car. Only this vehicle is worth $5.5 million. You certainly don't want to smash it, so be careful. You've reached a depth of 6,600 feet. Don't even think about getting out of the submarine. The pressure here is 200 times greater than on the surface. Your body just won't survive this experience. There's still almost 30,000 feet to the bottom of the Mariana Trench. If you teleported right there, a huge column of water nearly 7 miles high would press down on you with all its force. Your sightseeing tour would be over before it began. Even pressurized submarines can't withstand that kind of force. Large metal machines just burst like air balloons. At the moment, people only explore the bottom of the Mariana Trench with the help of robots and drones. One such machine is Nereus. This is an autonomous underwater vehicle that was built specifically for deep-sea diving. It can withstand pressures 1,000 times greater than those on the surface and reach a depth of nearly 36,000 feet. In May 2009, Nereus got to the bottom of the Challenger Deep, the deepest known point on our planet. Thanks to this machine and its 2 cameras, people could watch what was going on at that enormous depth. But people have also set foot in the Challenger Deep. Back in 1960, the Trieste bath escape descended to its bottom. The vessel was carrying 2 crew members. Unfortunately, they couldn't see their surroundings well. There was only one small window in the bath escape. It helped the structure of the ship remain strong. Plus, to withstand the incredible pressure, the iron walls of the bath escape were 5 inches thick. But when the explorers reached the ocean floor in the Challenger Deep, one of the window's panes did crack. Luckily, the ship was still able to spend about 20 minutes at the bottom of the ocean and then rise to the surface. But there are living creatures that are used to such incredible conditions. The Mariana snailfish, for example, lives at a depth of 24,000 feet. Even the bottom of the Mariana Trench is inhabited. Bacteria and viruses live there. They're used to low temperatures and high pressure. And their food is all kinds of organic matter that sinks to the bottom of the ocean. People can also survive in other extreme conditions. For example, in space. It's a vacuum. Unlike what many people believe, it's not cold. It's also not as dense as air or water. That's why you'd lose your body heat very slowly. But you can do an experiment. Normally, water boils at 212 degrees Fahrenheit. Let's say you place a glass of water in a special chamber and gradually lower the pressure. The lower it is, the lower temperature the water needs to boil. You're 70% water. And since space is an almost absolute vacuum, the pressure there is extremely low, near zero. And now, think about what can happen with your very liquid blood. I believe you can imagine the consequences. Ouch. Also, your internal organs would begin to expand. But that's not a problem. Your tissues are flexible and can withstand such an experience. The main issue would be the lack of oxygen. Without air, you'd soon lose consciousness. And still, if the rescue team could get to you within 1 to 2 minutes, you'd be fine. But there are living organisms that can survive even there. One bacterial species was thriving in outer space near the International Space Station for 3 years. These bacteria don't mind the vacuum and the lack of oxygen. They've even managed to survive strong solar radiation. They rightfully deserve the title of the world's most resistant bacteria. If you draw up a map, trace a line connecting the island of Bermuda, Puerto Rico, Miami, and back to Bermuda, what do you get? The infamous triangle, known for swallowing thousands of ships and aircraft over the centuries. But there's a new mystery to this already enigmatic place. Something's lurking deep in the waters below, and it's leaving bizarre clues of its existence. Splash! Your submarine hits the water surface. You descend 100, 1,000, 2,000, 3,000 feet. It's getting darker. The sub's walls creak as the pressure grows. Over 1,400 psi. It's like the weight of a grand piano squeezing every square inch of your body from all sides. You've made it to your destination. All that's left is to spot the beast. just in time. Among the black void, you see a bright green glow off in the distance. It's getting closer. As it approaches, it gets bigger. This is it! The creature that's been leaving strange circular markings on fish, dolphins, whales, and even other sharks. Behold, the cookie cutter shark! Don't let its size fool you. It may be no longer than a bowling pin, but this creature is a parasite. It attaches itself to other marine animals using its neatly arranged serrated teeth. With one bite, it fills its belly, detaches, and goes on about its day. Its mobile snack also swims away with its life. The only evidence of this rendezvous, a cookie-shaped mark on its body. Don't assume you're safe in your submarine. These bold little guys have been known to go after subs too. You decide not to risk the shark punching a hole in the only thing keeping you from being squished to a pulp by the surrounding water. You journey on to meet other bizarre creatures lurking in the Bermuda Triangle. At twice the depth, you'll find the dragonfish. Unlike other deep water inhabitants, these things produce light in the infrared range. Blue and green is what other fish stick to. This gives the dragonfish a huge advantage. It provides itself with light that other marine dwellers just can't perceive. Things that want to eat the dragonfish can't detect this light, as well as the critters the dragonfish likes to feed on. A truly unique deep-sea dweller is the vampire squid. Neither vampire nor squid, or octopus, this thing is a unique species of its own. It has the largest eyes compared to body size of any animal on the entire planet. When the vampire squid feels threatened, it curls its arms up and around its body. Essentially, the thing turns itself inside out. Another animal to avoid down here is the terrifying bobbit worm. It buries itself in the sea floor, leaving a small part of its body out. It waits for dinner time with its pincer-like mouth parts open. What's on the menu? Other worms and fish that can be 7 times bigger than the bobbit. It uses its 5 antennas to sense when lunch is close enough to snap. In an instant, the worm launches forward and grabs its lunch with its mouth parts. It's not done yet. Once it's got its jaws locked onto its lunch, the worm injects it with venom and pulls it down into the burrow to feast. One of the deepest trenches in the Bermuda Triangle is the tongue of the ocean. This is also the secret breeding grounds of tiger sharks. You'll instantly recognize them thanks to those darker gray tiger stripes on their sides. They're the second largest predatory shark species after the great white. And with a big size comes a big appetite. Marine mammals, smaller sharks, stingrays, and green turtles are all on the menu. If you ever come face to face with a tiger shark, hopefully not, remember this: you can tell the fish's age by looking at its stripes. They fade over time, so the younger the shark, the more pronounced its stripes. There's plenty of zooplankton in the Bermuda Triangle. These are, usually, small organisms that are essential to the ocean's food chain. But get this, if nothing ate them and they were left to grow out of control, zooplankton would cover the entire world in layers and layers in just 4 months. Oh, and the largest type of zooplankton is the jellyfish. Jellyfish were around long before dinosaurs. You probably know your body is 60% water. A jellyfish is 95%. So if it gets washed onto the shore, after a few hours, most of its body just evaporates into the air. There's also a jellyfish that lives forever. The immortal jellyfish can revert itself back to its polyp stage and then grow again. Sounds like something from another planet, but it's no space jelly. Those do exist, by the way. Back in the 1990s, NASA raised jellyfish in space to see what zero gravity does to them. They were just fine living up there in the cosmos. When they came back down to Earth, though, they had trouble adjusting. The European eel hasn't been to space, but it is quite a globetrotter. It travels all the way from Europe to the Sargasso Sea, where the Bermuda Triangle is located. In the larval stage, it just drifts around the ocean for as long as 3 years sometimes. It's also the chameleon of the sea. Over the years, the European eel changes color, going from translucent to yellow to metallic silver. They're nocturnal and secretive, pretty much the ideal companion to have when you raid the fridge at midnight. A giant squid over half the length of a football field once washed up on a Florida beach. Researchers suspected this behemoth came from the Atlantic Ocean near the Bermuda Triangle. Giant squids are the longest invertebrates, meaning they have no backbone. They also have the biggest eyes on Earth, ever. They're as large as a soccer ball. Another creature found near the Bermuda Triangle is Sterer's cave shrimp. They were so good at keeping to themselves that no one knew these creatures even existed until 2011. Some female cave shrimps carry an impressive number of eggs along with them. Scientists discovered one female had around 2,000 eggs attached to her body. The Bermuda petrel is the national bird of, yes, you guessed it, Bermuda. It's the second rarest seabird on the planet. In fact, people thought it was extinct until 1951, when they spotted a few on the island. It has an eerie cry that'll send shivers down your spine. The Nassau grouper can only be found on the coasts of South Florida. This fish lies in wait and ambushes its lunch of other fish, crabs, and lobsters. It's sort of like a vacuum cleaner because it inhales its food through its huge mouth. The fish has a cool defense mechanism too. Like the chameleon, it changes color when it feels it's in danger. Sometimes it takes on a lighter or darker shade of its own color to blend in with the environment. So, you may spot a Nassau grouper, or you may not. If you happen to visit the Bermuda Triangle, you'll probably see a hammerhead shark. They use that iconic hammer-shaped head to pin their lunch, stingrays, onto the ocean floor. The shape of their head also gives them better vision. They can see almost 360 degrees all around, above and below them. Well, save for one blind spot right in front of their nose. The hawksbill sea turtle may not look intimidating, but this guy will eat anything it can get its bird-like beak around. Sea sponges, algae, and even venomous jellyfish. A lot of the stuff on their menu is inedible for most, but their body fat can absorb the venom and toxins, so they go unscathed. The Bermuda Triangle is also home to green glowworms. They're not really worms, but larvae. They produce that bright light from an organ near their tail. This light makes smaller creatures come toward them, making it easy for them to catch their lunch. Most of the time, they look pretty ordinary, but they have an oddly fixed schedule. Every third night after the full moon during the summer, at an exact time, the glowworm lights up. But back to more nightmarish creatures of the Bermuda Triangle. There's the goblin shark, known as a living fossil because it's the only one left of its animal family. It's only about the length of your forearm and looks like nothing special. But watch closely as its lunch gets too close. Boom! The shark's jaw shoots out of its mouth and grabs onto the unlucky creature. Once the teeth have locked in, the jaw goes right back in the shark's mouth. And yes, you share the planet with this thing.
Roofs fly off like paper. Huge trees are yanked from the ground. Power lines snap and leave neighborhoods in the dark. Streets flood like rivers. Homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole. A huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, 2 thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather.
So here's the famous Grand Canyon in Arizona, a gigantic crack in the ground of incredible beauty and grandeur. Now, imagine it dozens of miles longer and lying at the bottom of the ocean. In fact, you don't have to imagine it, because you can see this scene in real life. A massive crack in the ocean floor lies about 620 miles west of Portugal. This mysterious rift is called the King's Trough Complex. It's a broad system of parallel trenches and basins descending into the dark depths of the Earth's crust. All of this awe-inspiring beauty stretches for about 310 miles. The deepest part of the system is known as Peak Deep. It's located at the eastern end and is one of the deepest places in the Atlantic Ocean. The Bermuda Triangle, the Mariana Trench, and other places, surrounded by mysteries, secrets, and legends, may fade into the background compared to the King's Trough complex. There are no frightening stories or records of vanished ships here, but just imagine it. At the bottom of the Atlantic Ocean, in icy waters where almost no light reaches, lies a giant unexplored rift. What's down there? What kind of creatures might be found? Perhaps there are remains of sunken ships. We are unlikely to find out anytime soon because reaching it is extremely difficult due to the immense pressure. For now, the only thing scientists truly understand is the origin of this underwater canyon. But first, let's look at how similar formations appear on the surface. The Grand Canyon, for example, was formed by a river. Meandering slowly over millions of years, it carved through the region, washing away and grinding down sedimentary rock. So here's the question. Do you think something similar happened to the floor of the Atlantic? Of course, there are no rivers there, but what about underwater currents? Could they have created such a giant, dark fissure reaching deep into the Earth's crust? Well, in fact, no. The origin of the King's Trough complex is connected to the movement of tectonic plates and the thermal activity beneath them. But how did scientists determine the cause? Well, the rift lies deep underwater in complete darkness. That wasn't a problem for researchers. They sailed to the site on a research vessel and used a powerful sonar system to create a detailed map of the area. After obtaining a clear picture of the terrain, they selectively retrieved volcanic rock samples from different parts of the trench using a chain bag dredge. After that, they delivered the samples to laboratories for chemical analysis. All of this data helped scientists discover that between 37 and 24 million years ago, this part of the North Atlantic temporarily became a boundary zone between the European and African tectonic plates. Tectonic plates are enormous slabs of rock that cover the Earth's crust like a planetary-scale mosaic. They move, collide, overlap, and push away from one another. The King's Trough complex formed during a period when the Earth's crust was splitting apart because of the movement of tectonic plates. It pulled away from east to west, resembling a giant zipper being undone. Now, in addition, scientists found evidence that the crust in this area was subjected to intense heating, rising from deep within the planet. Although researchers don't know exactly what occurred, it's likely that hot material, known as a mantle plume, rose toward the surface. All of these events deformed and fractured the Earth's crust, leaving us with what could be called an underwater Grand Canyon. But why are we interested in this at all? What does knowledge of events that happened tens of millions of years ago give us? Well, scientists now better understand how processes deep within the mantle can influence the movement of tectonic plates. This major research also provides insight into the geological evolution of the Atlantic seafloor. All of it helps humanity better understand similar processes taking place today. For example, near the Azores, another giant system of trenches known as the Tercera Rift is forming right now. What will happen next to this rift? Is such an event dangerous for people? One of the reasons scientists conduct these studies is to answer questions like these. It's unknown what secrets may still be hidden within that underwater fracture. But let's return to land and our beloved Grand Canyon. Even though it is famous worldwide, there are things inside this canyon that may surprise you. The Grand Canyon is ancient, yet it continues to change. Rock erosion happens slowly, but with each passing year, the canyon grows deeper and its shape evolves. Now, if you plan to visit the Grand Canyon, prepare for unpredictable weather. The canyon has its own climate, which can differ from the surrounding region. Because of the dramatic elevation changes, temperatures constantly shift. Snow may fall along the rim, while not far below, people inside the canyon enjoy warm sunshine. Walk a little farther and higher, and you might find yourself in the rain. Take shelter lower down, and you could end up surrounded by fog. So plan your route carefully and check forecasts from official weather services. There's both good and bad news for archaeologists. In the Grand Canyon, you can find ancient fossils of marine creatures more than 1 billion years old. In its caves, there are traces of land mammals dating back 10,000 years. The bad news is there are no dinosaurs here. The canyon most likely formed after those ancient reptiles became extinct. Now, one thing that may surprise you during a hike through the Grand Canyon is Supai Village, with a population of about 200 people. It's located at the base of the canyon within the Havasupai Indian Reservation. It's the most remote settlement in the continental U.S. and the only place in the country where mail is still delivered by pack mule. There are no roads leading to the village, and if you want to visit it, you'll need to prepare for a challenging hike along steep slopes under the blazing sun. Beyond its fascinating natural features, the Grand Canyon also has things that are almost fantastical and eerie, at least according to rumors and legends. For example, there's a hotel room known as the Grand Canyon Cavern Suite inside the canyon, deep within one of the caves. At a depth of 220 feet, guests find a luxurious room with all the comforts and, according to some accounts, something unsettling. Some visitors have reported stones moving inside the room, frightening dancing shadows, strange sounds, and movements near the bed where they were sleeping. You might also hear many local legends about spirits and monsters that inhabit the canyon. Of course, these are just stories, but some truly tragic events have taken place here. The canyon has become a grave for many people. Over time, around 800 people, according to official records, have passed away here. There were accidents, mysterious incidents, and real tragedies. For example, in 1956, 2 airplanes collided in the sky above the canyon. And that was far from the only case. So be careful when you come here. Stay away from the cliffs and keep close to your group. There is also a theory that ancient advanced civilizations once lived in the Grand Canyon. These rumors began in 1909 when a local newspaper published a major article claiming that 2 archaeologists from the Smithsonian Institution had discovered a secret tunnel filled with Egyptian artifacts and mummies. The Grand Canyon and ancient Egypt? How could that be possible, considering the vast distance between them? Soon after the article was published, the Smithsonian Institution issued a denial. No archaeologist from the institution had conducted such research, and certainly none had found Egyptian artifacts. Many believe the newspaper had published a hoax, although some suggest the institution deliberately concealed information about hidden discoveries. In any case, the story seems highly unlikely. Now, even though you know all this and want to see something similar yet different, you should travel to Tibet, where the Yarlung Zangpo Canyon is located. It is 2 miles deeper and 30 miles longer than the Grand Canyon. There, you would also see many fascinating things, but that's a topic far too large and deserves another video. Now, the Mariana Trench is the deepest and probably the most enigmatic place on Earth, whatever that means. Bizarre creatures, such as deep-sea anglerfish, frilled and goblin sharks, barrel-eyed fish, hatchet fish, live in a crescent-shaped trench in the western Pacific. Just 3 people have ever descended down the Challenger Deep in the southern end of the Mariana Trench. There, at a depth of almost 11,000 feet, vents are bubbling up carbon dioxide and liquid sulfur. Mud volcanoes erupt under the pressure 1,000 times greater than at the surface. And so, it's no place I want to go. So bye!
Get back in there.
Alright, since you clicked, yeah, you're about to visit places no less mysterious and creepy than the Mariana Trench. Your first stop is Mexico, the Yucatan Peninsula to be precise. See those bottomless sinkholes filled with crystal clear water? It's fresh water that overlies salt water seeping from the sea. The sinkholes are called cenotes. The Mayans believe these natural wells were the gateways to the underworld. Thousands of cenotes, created by collapsed limestone bedrock, form one of the world's longest underwater cave systems. You can easily get lost in this tangled, mysterious network. Now it's time to visit the Caribbean. There, you'll get to a depth of almost 8,000 feet to see the Van Dam vent field. The hydrothermal vents fire out streams of muddy, scalding water with a temperature reaching 400 degrees Fahrenheit. That's almost enough to bake a pizza. These mounds are made of talc, a substance you can find in baby powder. The Van Dam vent field is an oasis for odd species. One of those is kind of a creepy shrimp without eyes. Instead, they're equipped with patches of light-sensitive cells on their backs. Now, you don't have to travel far away. The next enigma on your list is also in the Caribbean. Just off the coast of Belize, there is a giant sinkhole. It's also blue. Yep, that's the Great Blue Hole. The thing is about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave until rising waters filled it, making it collapse in on itself. The deeper you descend into the Great Hole's crystalline waters, the darker it becomes. You see tons of stalactite-filled caves, but don't even try to enter them unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you notice the water shimmer. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. Time to get out of there. Who knows what you might come across in the murky depths? Your next destination is off the Pacific Northwest coast. Almost 500 streams of methane bubbles were discovered there several years ago. Because of the bubbles, the vents got the name champagne seeps, which sounds better than the fart spas. Scientists are still puzzling over this phenomenon. Where does the methane come from? Underwater cows? Why is its temperature warmer than that of the surrounding ocean? And most importantly, what would happen if you managed to light a match somewhere near a large bubble? Methane is a highly flammable gas, and setting a methane bubble on fire, well, you get the picture. And now you're off to Iceland. The plan is to dive into Silfra, a fissure filled with pure glacier water. This 206-foot deep crack is the only underwater place on the planet where you can touch 2 continents at once. The deeper you go, the darker it becomes. The rocky landscape looks otherworldly. Divers who dare to visit this incredible place risk having their gear frozen, getting hypothermia, or not surviving whatsoever. After all, the water temperature in Silfra Fissure is about 35 degrees Fahrenheit year-round. Your next destination is Scotland. Okay, cue the bagpipes. If you dive in the Gulf of Corryvreckan, a narrow strait between 2 islands, you'll see massive underwater rocks and deep holes. They create the 3rd largest permanent whirlpool on the planet, the Corryvreckan Maelstrom. The water moves through the strait at breakneck speed. It hits the underwater rocks, and the place looks like a pot with boiling water. The waves, created in the process, sometimes reach a height of 15 feet, and you can still hear the roaring whirlpool from 10 miles away. It's believed the Corryvreckan Maelstrom has swallowed dozens of sailors over the centuries. They were caught unaware by the ferocity of this natural phenomenon and pulled underwater in the blink of an eye. Okay, enough bagpipes. Your adventures are getting more and more extreme. You're heading for Antarctica. There, in the Southern Ocean, you'll find the Ross Sea Ice Shelf. Say that 5 times real fast. Later, not now. It's roughly the size of Spain, with the ocean underneath containing as much water as the North Sea. Once, scientists drilled all the way down through this enormous chunk of ice. Imagine their astonishment when they found life in those extreme conditions. The researchers came across dozens of mysterious species not known before. The most unnerving were upside-down swimming fish and overturned sea anemones hanging in the frigid waters. Hopefully, bizarre places with a notorious reputation don't frighten you. Well, too bad, because you're about to visit the Bermuda Triangle. It's an area between Bermuda, Florida, and Puerto Rico where planes and ships seem to vanish in thin air. For the first time, this place attracted a lot of attention in 1945. That's when 5 U.S. Navy planes disappeared during training. Before radio contact was lost, the flight leader said, "We're entering white water. Nothing seems right." After that, the planes with 14 men flying them disappeared. Even scarier, a rescue plane with 13 people on board never came back as well. Some people believe the mythical city of Atlantis lies at the bottom of the triangle. They claim its inhabitants use extraterrestrial technologies to sink ships and crash airplanes. Others blame rare and unexplored natural phenomenon, for example magnetic anomalies, or massive pockets of flammable methane gas. There we go again. Then, if a bolt of lightning ignited a giant methane bubble near a ship or a plane, this could probably make it sink without a trace, except the smell. But methane is found everywhere all over the world, and it never behaves this way. Some experts aren't sure there's a mystery to explain whatsoever. Lots of busy routes pass through this area. No wonder more ships and planes sink there than anywhere else. Now, prepare some warm clothes. You're heading for the north again. Your destination is Cape Desolation in Greenland. Nice place. In 2012, Canadian researchers were sampling the water in that area, and their equipment came back to the surface with pieces of coral attached to it. That's how a cold water coral reef was stumbled across. These unique pinkish corals can easily go without sunlight and live in strong currents 3,000 feet below the surface. Another unique spot you can't miss lies between Greenland and Siberia. The Gakkel Ridge is the deepest and most remote portion of the global mid-ocean ridge system. In some places, it reaches the depth of more than 3 miles. It's only natural the darkest corners of this underwater world remain unexplored. Fascinating chemical reactions happening at the bottom of the ridge produce hot fluids rich in minerals. They spew, like freshmen at a rush party, from seafloor vents. And since these vents are isolated from the rest of the ocean, they're hot spots for bizarre creatures found nowhere else in the world. Your next stop is just off the coast of Cuba. Circular columns, paved floors, symmetrical stone structures. That's what the Cuban underwater city looks like. What happened there? Why was a large city abandoned at a depth of more than 2,000 feet? Lots of people believe those are the ruins of a long-forgotten civilization. But scientists have their doubts. They claim the lost city is nothing but a natural phenomenon that appeared about 5 million years ago. The disc and donut structures often appear around the areas of the seafloor where natural gases break free. Again with the gases. When you come to visit the Sargasso Sea in the middle of the North Atlantic Ocean, you won't find its shores. Instead, it's surrounded by powerful ocean currents. These are the same currents that turn the sea into a gigantic convention for dense brown seaweed. In the 19th century, a French ship was discovered in the Sargasso Sea. Its sails were set, but not a single crew member was on board. This mysterious disappearance made people believe the seaweed was carnivorous. The Sargasso Sea is indeed a weird place. It's always eerily calm and unnaturally warm, even though it's surrounded by the churning, freezing waters of the Atlantic Ocean. Could one of these bizarre places become a home to the largest marine predator ever, the megalodon? The giant shark's teeth, some larger than an adult man's hand, have been found pretty much all over the world. But since these creatures preferred warm, shallow waters, they lived along the coastlines of all continents except Antarctica. In other words, it'd be a waste of time to search for the giant predator in the depths of the Mariana Trench, in Greenland, or in Mexican cenotes. But then, could it choose the waters of the Caribbean to hide from the hustle and bustle of the modern world? Don't get your hopes up. There's been no proof the megalodon does exist these days. It wasn't a shy, elusive animal, and still, no one has seen this shark lurking around recently. Not even near the fart spas.
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, the twilight zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration, as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, the planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 freefall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produced many unusual sounds and rumbles, but, that's a subject for another video, or my next annual review.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
You know how they say it's better to just hand over your wallet if you run into a mugger? Instead of surrendering their wallets, sea cucumbers choose to spit out some of their insides to fend off predators like crabs and fish. It's a natural defense mechanism for them, and they quickly grow those organs back in just a few days, thanks to special cells inside their bodies. It's not the only weird thing sea cucumbers do. They can actually breathe through their rear end. They have this thing called a respiratory tree that connects to their backside and sits right next to their intestines. So when they suck in water from their behind, it goes into that respiratory tree, letting them absorb oxygen directly into their fluids. Plus, sea cucumbers are the janitors of the ocean. They munch on whatever gets stuck in the sand on the ocean floor. Once they've eaten, they manage to clean out the sand, leaving it nice and tidy after they do their business. As for the clean sand, the stunning white sand beaches in Hawaii are actually a product of parrotfish number 2. These fish munch on algae from rocks and dead corals, and while they're chomping away, they also grind up the leftover bits of coral in their bellies. When they're done, they move their bowels, and voila! It all comes out as beautiful sand. Not only do they play a vital role in keeping the coral reef ecosystem healthy, but they can churn out hundreds of pounds of this white sand every year. Marine animals are seriously impressive when it comes to holding their breath. Just look at sperm whales and elephant seals. They can stay underwater for a mind-blowing 2 hours. Then there's a Cuvier's beaked whale, which holds the crazy record at almost 4 hours underwater. When you compare that to the human record of 24 minutes and 37 seconds held by pro diver Budimir Shobat, it seems pretty insignificant. But what's the marine animal's secret that helps them excel humans this much? Unlike us, these sea creatures have a ton of hemoglobin and myoglobin in their blood and muscles, allowing them to store way more oxygen. When their oxygen runs low, myoglobin steps up and releases even more. Plus, they can tolerate higher levels of CO2, so they don't feel the need to breathe as quickly. There's even a study that found their myoglobin molecules have a unique charge that keeps them from sticking together, which boosts oxygen storage. And on top of all that, they can slow down their heart rate and restrict blood flow to hang out underwater even longer. Rumor has it that about 540 million years ago, a meteor loaded with frozen octopus eggs smashed into Earth,
Sounds like a delirium, but some scientists are entertaining a very questionable idea that octopuses and their cephalopod buddies, like squids and cuttlefish, might actually have some extraterrestrial origins. The thing is, cephalopods have extraordinary DNA that doesn't look like any other DNA on our planet. They've got around 33,000 protein-coding genes in their genome, which is way more than what we humans have. A recent study suggests that their evolutionary story shows some odd traits that might hint at a connection to space, like they could be from some super far-off past, or even the future. The researchers went as far as to claim that modern octopuses could be the descendants of these frozen creatures that hitched a ride on comets and splashed down in our oceans. And why octopuses? Well, they really stand out in the animal kingdom. They can use different tools to build their own houses, and they can even solve everyday problems independently of their brain, as 2/3 of an octopus's neurons are in its arms. These traits seem to have just appeared out of nowhere during evolution. They even tossed around another quirky theory. What if an extraterrestrial virus crashed into early squid populations and gave them a crazy boost in evolution, turning them into the octopuses we know today? Anyways, these are just fun speculations without any hard proof. Now, this funky object is an animal, not a rock. It's called sand dollar. Just look at the shape of its shell. Once sand dollars are exposed to the sun, their shells lose their soft, spiny covering and become bleached white. Back in the day, beachcombers thought these shells looked a lot like big silver coins, kind of like the old Spanish dollar that was about the same size. But if you prefer, you can call them sand cakes instead. These quirky creatures have tiny spines on their surface, and they glide along the ocean floor. They use small tube feet that line the grooves on their underside to grab bits of food like plankton and algae, which they then send to their mouths. Inside, they have 5 triangular teeth that help them munch on their meals. In some Georgia folklore, sand dollars are said to represent coins lost by mermaids. Sand dollars have a unique talent for cloning themselves. They can do this for a bunch of reasons, like when a predator comes around. Some species of sand dollar larvae can actually split in half as a defense mechanism. It takes about 24 hours for them to clone themselves, and the new larvae end up being about 2/3 smaller than the original, which helps them hide from danger. Wait, is that a giant sea hot dog racing through the ocean? Sorta. Some scientists have joked that sperm whales seriously resemble enormous hot dogs. These massive creatures can take quick naps, standing up for about 10 to 15 minutes. They only sleep about 7% of the time, mostly between 6 p.m. and midnight. Sperm whales also have a cool ability to retract and extend their eyes, thanks to a thick retractor muscle around them, but they can't actually roll their eyes in their sockets. Plus, they have the most asymmetrical skull of any mammal out there. Oh, and let's not forget, they have the largest brain of any living creature, weighing in at over 9 pounds. Unlike us humans, if dolphins went into full-on snooze, they'd stop breathing and could drown. So they figured out a genius solution. They let only one side of their brain sleep at a time. This means one half stays awake to keep them breathing and watching out for any potential threats. When they snooze, they only close one eye. If their right brain is resting, their left eye is shut, and vice versa. This unique sleep style is called unihemispheric sleep, and it lets them recharge without ever fully losing awareness. On top of that, dolphins might be using corals and sponges like their own little pharmacies. Scientists have seen them rubbing their bodies against specific types of coral and sponges, suggesting they might be treating skin issues. They've even spotted dolphins lining up to take turns at these spots, using corals like Gorgonian coral Rumphella aggregata, leather coral, and some sponges. What's really fascinating is that researchers have analyzed these corals and found they contain compounds that could help with dolphin skin conditions, which can sometimes lead to infections and lesions. Now, the big question is figuring out exactly how each type of coral helps dolphins, and if it really boosts their health overall. Sea urchins aren't exactly the Usain Bolts of the ocean. They move slowly by crawling with their tube feet and occasionally give themselves a little push with their spines. These little guys have just 5 teeth, which they use like a beak to scrape algae off rocks, which I'm pretty sure is the ocean's version of an all-you-can-eat buffet. But since all that scraping wears their teeth down, they're in a never-ending dental replacement program. Scallops are the underwater equivalent of the world's most confused security cameras, sporting up to 200 tiny eyes on their shells. These eyes are high-tech. They can even adjust their pupils to light. Instead of working like ours, scallop eyes have a unique setup. Light goes through a pupil, lens, 2 retinas, and then hits a mirror made of guanine crystals that reflects it back. Scientists were puzzled about how they see since their main retina often gets blurry light. But it turns out, scallops can change their pupil size by about 50%. Just don't expect them to do it in a hurry, as it takes a few minutes.
Now here's something really neat about orcas. They're expert hunters, and they do it in groups called pods. A pod can consist of up to 40 orcas, forming a very effective hunting team. Interestingly, there are distinct types of pods: resident and transient. Resident pods are more into fish, while transient pods have a taste for marine mammals. But no matter what type of pod they belong to, all orcas have one thing in common: they are master collaborators. They work together using smart hunting techniques that are often compared to the teamwork of wolf packs. Almost 95% of jellyfish's body is made of water. For comparison, the human body is 60% water. It's probably not a surprise since jellyfish don't have a heart, blood, eyes, or brain. The other 5% of their body weight is proteins, muscles, and nerve cells. Jellyfish have been around for more than 500 million years. This makes them older than dinosaurs. These creatures haven't changed much, and today's jellyfish are pretty much like their ancestors. Electric eels have small eyes that are not so effective in environments with no light, so they mostly rely on their electric organs. Those consist of 6,000 cells. Eels use them to stow power, similar to batteries. These creatures use electricity like bats use their radars or dolphins their sonar. An eel can also produce enough electricity to power a panel of light bulbs. There's a small tropical archer fish that can learn to recognize human faces. This fish has an interesting ability to spit small jets of water from its mouth. Researchers showed the fish the image of 2 different faces placed side by side. One was unknown and the other was familiar. The fish was supposed to spit water at the familiar one. The creature took the right guess more than 80% of the time. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. Iguanas use their long claws to hold on to the bottom when they need to graze. Green turtles can cross over 1,400 miles when migrating. They try to find the perfect spot to lay their eggs. Penguins sort of fly when they're underwater, reaching a speed of 25 miles per hour. More than 5 million years ago, I've heard, I wasn't around then, deep-sea worms and humans had a common ancestor. So we still share 70% of our genes with these creatures, and with sea stars, squid, and octopuses. Now, octopuses are in fact incredibly old. The oldest known fossil belongs to an animal that lived almost 300 million years ago. FYI, this is before our dinosaur buddies roamed the Earth. Wait, there's more! Octopus arms have a mind of their own. That's because 2/3 of their neurons lie in their arms, not in their heads. This means that their arms can problem-solve how to open a shellfish, while their owner is worried about other stuff entirely. Talk about ninja-level multitasking. Oh, and like other animals, such as chimpanzees and dolphins, octopuses have proven to be good at maneuvering tools, like picking up old shells and using them as a temporary home. Now, of course, the most intelligent animals on our planet are humans, according to humans. But we don't seem to give pigs enough credit. Pigs are so smart they can play video games. No, not Minecraft. But in a recent academic study, scientists had 4 pigs play a joystick game. They had to manipulate the stick so that the moving ball would hit the wall and then they would get a treat. All 4 pigs did great in the test, which was surprising even to the scientists. Now, pigeons also aced an impressive test. They were trained to differentiate a Picasso painting from a Monet one, which they had no trouble learning. Then they were able to apply this knowledge, identifying works of art they had not previously seen, meaning they really understood the difference between each painter. Poor things are always seen as a nuisance. Now, if we placed kangaroos in an Animal's Most Amazing Ability contest, they'd win. It's mainly because they break the 4-legged rule. A special species of kangaroo, the red kangaroo, uses its tail to help propel it forward. Now, visually, it has 4 limbs, but in practice, it uses 5. They're biologically built to use their tail as a 5th limb, since it's packed with articulated vertebrae and thick muscles. Of course, it had to be an Australian animal. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey. Now meet this guy. Unlike what its name might suggest, the red panda is closer to a raccoon than it is to a giant panda. You'll find a lot of these cat-sized creatures in the Himalayan region, hopping from tree to tree and bundled together trying to keep warm in the harsh weather. They're gentle and friendly like their big panda cousins, and occasionally enjoy eating some bamboo sticks. And then there are bees. Compared to humans, bees' brains are the size of pinheads, yet they are capable of astounding things. Let's say a bee is running low on energy after a long search flight. This bee desperately needs a drop of honey in order to continue flying, but smartly enough, she doesn't need to go back to the hive to recharge. She can ask a fellow beehive mate for a drop of honey directly from this other bee's stomach and continue flying. This type of decentralized system allows them to build highly effective societies, one that bees don't need to push the queues in front of the honey cells, for example. Every year in the winter, great white sharks that live along the California coastline disappear. It feels as if they take a vacation for 30 to 40 days. The animals go to a point halfway between Hawaii and Mexico. They might do it to get some food, relax, or hang out with their buddies from other areas. The spot is now called the Whale Shark Cafe. Some types of sharks, like makos, whale sharks, or white sharks, breathe in a very specific way. It requires them to swim all the time. They also need to move quickly and with their mouth open. This way, the oxygen can enter and reach their gills. Sea sponges are some of the most primitive animals. They're immobile, don't have a mouth, eyes, bones, brain, heart, lungs, or any other organ whatsoever, and still, they're alive. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. There's something known as the orange cat behavior, and apparently it's not just a meme. So far, scientists have been able to understand that coat color is connected to a feline's gender. And since orange is an X chromosome, orange cats are usually males, like Garfield. The so-called orange cat behavior describes ginger cats as agents of chaos. Again, pretty much like Garfield. However, there haven't been any conclusive studies on whether coat color and cat behavior are truly linked. In terms of vision, mantis shrimps probably have the most psychedelic vision out of all animals. These funny-looking creatures have a whopping 16 varieties of photoreceptors, with 5 of them reserved for the ultraviolet or UV spectrum. Ultraviolet rays are really short wavelengths, which are invisible to humans. The thing science still doesn't understand is how exactly these mantis shrimp view the world around them. Sure, they can perceive a bunch of colors, but they can't necessarily distinguish all of these colors among themselves. It can be that they just see a lot of really vivid, really blurry colors, but we haven't figured out a way to check that out. Now, to say sloths are cute is an understatement. They may be one of the friendliest animals in the jungle, but there's more. If you look closely at their fur coat, you'll notice hints of green. These greeneries are actually tiny little algae that grow alongside sloths. They help sloths to camouflage better in the jungle, but they also nurture them. The little cracks inside a sloth's fur create the perfect environment for algae reproduction, and scientists have found species of algae that don't exist anywhere else in the world. They do get by with a little help from their friends. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey.
Deep under the Indian Ocean, there's a giant patch where gravity doesn't work like on the rest of the planet. I mean, the gravitational pull works constantly, but Earth is not a regular sphere. Its surface is not smooth. It's covered with lumps and bumps like a potato, because our planet is not the same everywhere inside. Some parts are denser than others. Let's say you could pour water across Earth's surface. The shape this water would make is called a geoid, and it's like that because of the differences in materials inside the planet. That's why gravity isn't the same everywhere. And down there in the dark depths of the Indian Ocean, it's weaker than usual. That spot is something we consider a giant gravity hole that stretches more than 1 million square miles in size. It's roughly where the ocean floor sinks down in a giant depression. Scientists used ships and satellites to figure out this mystery. They realized the water level near India was lower because of this weak gravity spot. They're still not sure what made gravity become so weak in that area. But 2 Indian researchers realized everyone was trying to understand this considering what that area looked like in the present. So they decided to go to the past. They used computers to make models of a virtual Earth and figured out that the answer could lie over 620 miles under the surface. That's where a part of an old ocean sank 30 million years ago, causing a hot melted rock to move around. And this mixture might have made gravity weak in that area. It's a really interesting idea, but it's still not the final answer. In 2018, a team of scientists from India went to the Indian Ocean with special machines to listen to the ground rumbling, similar to when you hear thunder. They found out there were hot streams of melted rock coming up from deep inside Earth. Could they be part of the reason why the gravity is weak there? We'll need more information to understand the issue better, maybe even go back further into the past. For instance, about 140 million years back, the land was all connected as a big piece called Gondwana. But then, India started moving away from it. While India was moving, an old ocean floor called the Tethys Sea sank into Earth's insides. These two scientists from India kept trying to solve the case, using computers to pretend to be going back in time. They checked how the land moved, as well as the mantle, which is basically a thick layer of hot, solid rock. The duo found out that a long time ago, there were hot, light rocks rising from deep inside Earth. These rocks created a spot where gravity was weak. This spot was like a big dent in the ocean floor. The more these rocks rose, the deeper the dent became. The first of these rising rocks popped out around 20 million years ago to the south of the weird gravity dent. As these rocks moved and went under the land, the dent got bigger and stronger. The two scientists think these rocks were pushed up by the sinking old ocean floor, like bubbles. This process disturbed something called the African blob. You gotta see this. Deep inside our planet, there are two very big blobs, like giant pieces of rock, as large as continents. One is under Africa, and the other is under the Pacific Ocean. These blobs have roots that start almost halfway, 1,800 miles, toward the center of Earth. And they're probably the place where columns of hot rock rise up from way down below. When these hot rock columns reach the surface, big volcanic eruptions happen, and we're talking about some really massive ones that might have even played a role in erasing dinosaurs from the face of the Earth a long time ago. So, we don't want these giant blobs to be disturbed. Anyway, not all scientists agree with the theory about why gravity doesn't do its job in this particular spot in the Indian Ocean, saying they need more proof to be sure about these rising rocks. The real answer might come from listening to Earth's rumbling. Plus, who knows if this gravity hole will stay there forever or move away. It depends on how Earth's mass will shift around. To see some changes might take a very, very long time, maybe even hundreds of millions of years. That's not the only region where gravity works in mysterious ways. Or at least, that's what it feels like when you see certain things around the world. Like, what if you saw rocks that don't sink, but can float on water for a very long time? They can even travel around for thousands of miles until they finally find a spot where they sink. Scientists figured out how this worked by using special X-rays to check the insides of these rocks. And these unusual rocks turned out to be very light and full of tiny holes. Researchers used wax to cover pieces of these rocks and went with a special X-ray method to look inside the rocks to see how much water and gas was there. The reason these rocks can float is because of something called surface tension, which is like a very thin, the size of a human hair, layer of air on the water's surface. This helps some animals, like lizards and insects, to really walk on water. And these floating rocks are not just cool because they travel, but also because they can actually help scientists find underwater volcano eruptions. They can also carry living things across oceans since they tend to collect some plants and other things rich in nutrients. So it's basically like a free cruise, until you sink down at some random spot. No iceberg needed. Here you have floating rocks. And in Death Valley in California, there's a strange phenomenon where big rocks move across a dry lake bed and leave trails behind them. People wondered how this was possible for 60 years until the case was solved. Some thought there must be strong winds moving these rocks, or maybe even ice. But scientists found these winds aren't really strong enough to move such big boulders. They placed cameras on cliffs near the rocks, even though they were hard to reach. They did this for 3 winters in a row to study the temperature, rain, and wind in the area. Their idea was that ice might lift the rocks and let the wind push them. To test this properly, they put a rock in a container with water and sand and froze it. When they later pushed the container, the rock moved like it was on ice. This experiment helped prove their theory. And what's interesting is that the rocky area in Death Valley is similar to one of Saturn's moons, Titan. So these weird things on our planet may help us understand other phenomena, even in space. The reverse waterfall in England is an example of a spot with weird gravity too. You can find it not far from Hayfield. It has water that looks more like a fountain than a waterfall, considering it goes up toward the sky. But it turns out gravity doesn't have anything to do here. It's just the wind. It's so strong that when the water falls down, it catches it and pushes it back up. But where does this constantly strong wind come from? You can see a similar thing at Hoover Dam in Nevada, US. Try to climb up the dam, 726.4 feet, and pour some water out of a bottle. Not working? Yep, the water won't flow down as it normally would. It will fly up. You'll have the same result if you throw some light object from the same height. You will get it back. And this happens because of the strong airflow too. So these things seem like gravity is messing up with us. But there's always a logical answer behind that. Hopefully, we'll get one for the gravity hole in the Indian Ocean too.
A college sophomore finished her shift at the cafeteria and decided to go for a hike. She got dressed, said goodbye to her roommate, and hitchhiked a ride to the start of a trail. The 18-year-old girl met some hikers who were coming back and asked them for directions. It was getting dark, but the student pressed on, and she was never seen again. Her name was Paula Jean Weldon, and she went missing in 1946. She was walking along a trail near Bennington, a town in southwestern Vermont. The next day, her roommate reported her missing. The authorities quickly organized a search party. Hundreds of people searched the woodlands around the trail for 4 weeks. Her college even shut down for a while so students and faculty staff could join the search. They came back empty. The girl had disappeared into thin air. Paula didn't pack a bag. She didn't take any extra clothes or money. All the evidence suggested she didn't expect to be out for more than a couple of hours. Her father was a well-known industrial engineer. He blamed the county sheriff for poorly conducting the investigation. Despite all the efforts, the poor girl was still nowhere to be found. Her case remains unsolved to this day. But this is not the first time someone went missing in Vermont's forests. A year earlier, Mitty Rivers, a lively 74-year-old man, was the guide for a group of 4 hunters. He reached a fork in the road with his son-in-law. Mitty said he would walk a short distance down one of the paths. After all, he didn't want to miss lunchtime back at the camp. But that was the last time anyone had saw him. The group he had accompanied searched for the man all afternoon before calling the police. A more extensive search followed, but it didn't yield any results. The local man was an experienced hiker, and he was well familiar with the trail. Still, he had gone missing. Firefighters, volunteers, and even servicemen couldn't find the missing person after a month of searching. All that they found was a cartridge he dropped in a nearby stream. The local authorities still haven't solved the case. Nobody knew at the time, but Mitty and Paula were just the beginning. In just half a decade, 5 people in total disappeared in this part of Vermont. Years went by, but still nobody could explain their disappearances. And that's why the area got its name, the Bennington Triangle, after the famous Bermuda Triangle, where ships and planes have been disappearing for centuries. In 1949, the most puzzling disappearance happened in the Bennington Triangle. A 68-year-old veteran boarded a local bus. He was going home after visiting his relatives in St. Albans. His family took him to the bus station, and there were 14 witnesses who claimed he was still on it at the last stop before Bennington. But he never got off the bus there. His luggage was still on the rack, and an open bus timetable sat on his empty seat.
The man had apparently vanished into thin air while on a moving bus. And there's another weird thing. He disappeared on the exact same date the college student went missing 3 years ago. The youngest person to mysteriously vanish was an 8-year-old. He was with his mother while she worked on the family farm. She went to feed the pigs and left her son alone for an hour or so. When she came back, the woman couldn't find her son. The locals soon formed search parties and the local sheriff brought in tracking dogs. They picked up the scent but lost it suddenly at a nearby crossroads. The guy was never found. Again, there was a strange element to this story. The youngster was wearing a bright red jacket. This would have made him more visible to the rescuers. But more strikingly, Paula, the college sophomore who disappeared 4 years earlier, also had a red jacket. The final disappearance happened just 16 days after the little fella vanished from the farm. A 53-year-old woman was camping with her family in the Green Mountain National Forest. She went for a hike with her cousin, but there was a mishap. The woman fell into a stream. She decided to go back to the camp to change clothes. Her cousin thought she would join him later and continued along the path alone, but the woman never came back. In fact, she never reached their base camp. For 2 weeks, 300 searchers scouted the woods. They brought in helicopters, but found no trace of the unfortunate woman. The last disappearance in the Bennington Triangle had an ending. Not a happy one, though. In the spring of the following year, the searchers found the poor camper 3.5 miles from the original campsite. They had previously covered that spot, which made it only more mysterious. It was impossible to determine why and what happened to her. The only thing these 5 disappearances have in common is the period of time and the geographic area. 36 square miles of thick woods in the southwest of Vermont. This remote area of Green Mountains wasn't the happiest of places. Bennington and the nearby village of Glastonbury were founded as mining and logging towns. The living conditions were harsh. Near the end of the 19th century, the locals tried to rebrand the area as a tourist destination, but the mountain was unstable and a huge flood washed away their dreams of a happy life. Residents started moving out. In 2010, only 8 people lived in Glastonbury. It became a ghost town. In the late 1940s, the area was back in the spotlight for all the wrong reasons. But how could these disappearances have remained a mystery for so long? Surely someone had a reasonable explanation. One theory suggests that it was a case of foul play. Maybe an unknown person was up to no good and harmed the unsuspecting people. But then there would have been a pattern, and there is none. Or maybe the elements were responsible. The college student went missing on a pleasant day at the very beginning of winter. She was lightly dressed because it was 50 degrees Fahrenheit outside. But in the evening, the air temperature plummeted. It was a freezing 9 degrees Fahrenheit the following morning. In this part of Vermont, the weather is quite unpredictable. It can get really windy, especially in winter. Perhaps the bad weather and the dense forest confused the missing people. Recently, a strikingly similar case of disappearance happened here. A college student got lost in heavy fog at the top of Glastonbury Mountain. When he didn't return home, his fiancée called the police. State troopers immediately went out to look for him, but it was too dark and foggy to see anything. Luckily, they found him the next morning. He got lost because of the thick fog. He managed to find his way back to the trail only after the weather conditions improved. This story had a happy ending. But could this incident explain what happened to the people who disappeared over 70 years ago? The mountains around Bennington are full of abandoned mine shafts, a reminder of the town's history. A hiker lost in fog could easily fall into one of these wells. They could have no way of getting out. The area is so remote that no one would ever find them. The second danger are wild animals. Black bears are native to New England. Local hiking clubs advise visitors to store their food in special boxes, not to attract bears. The Green Mountain National Forest sits in the middle of the Bennington Triangle. Today, this popular recreation area is within a day's drive of 70 million people. People come here to camp, hike, and ride mountain bikes. But do all of them know about the 5 mysterious disappearances? I guess I wouldn't dare venture into this remote patch of Vermont's wilderness now.
So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name: the bloop. At first glance, the bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise traveled through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the Oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature, lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s deep in the South Pacific during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So researchers called it the bio-duck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory, announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise, so consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, all these sounds are of a natural source. volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah,